Hi everyone. In last lecture series, we have seen about the mechanism and working principle of reverse phase chromatography. And today's lecture series, we can see the mechanism and working principle of paper and thin layer chromatography. Paper and thin layer chromatography forms a very primary form of chromatography, as this method is used for testing the purity of compounds and also used for identifying various substances. And this is a very useful technique because it is relatively quick and it requires very minimum amount of samples for its quantification. Coming to paper chromatography, this type of chromatography mainly separates the compounds based on specified paper. Here this involves two different phases for their separation. First one is stationary phase and the second one is mobile phase. In stationary phase, water molecules highly gets bound to the inert material, that is cellulose matrix, which is used as a specified paper here. And in mobile phase, solvents can be used as in a combination. For example, butanol with acetic acid can be used as a solvents for separating different compounds. And in this type of chromatography, the solutes are highly separated according to their solubility, whereas it gets highly solubilized with the mobile phase or it gets attracted towards the stationary phase. And here the solvents and solutes get separated based on their polarity and also based on their solubility. This paper chromatography mainly involves two different types. One is descending paper chromatography, another one is ascending paper chromatography. This type is based on the flow properties of solvents as well as solutes. Whereas in descending chromatography, here in this method, the solvent is kept in the trough at the top of the chamber and is allowed to flow down towards the paper. Whereas the liquid moves mainly based on the capillary action and as well as gravitational force. Here, due to this action, the flow is more rapid than the ascending. This paper chromatography of descending order is represented in a diagram. In this diagram, the chamber that contains the solvent trough above the top surface of the column, whereas this is continued with the cellulose matrix of spot of sample. Whenever the solvent moves down towards the descending order, the spot also flows the compounds in the descending order. In this ascending order paper chromatography, the solvent moves against the gravitational force. Here the flow is only mainly due to the capillary action, so that the flow is very slow process. This paper chromatography setup is shown in this diagram, whereas in this setup we have a base chamber which is immersed with the organic solvent as well as with the cellulose matrix, which is spotted with the sample. Here the sample spot that is immersed in a particular angle of within the organic solvent will move the compound towards the top surface based on the polarity and also with the miscibility. Coming to thin layer chromatography, it is widely used method. This method is highly rapid process so that large amount of compounds can be separated easily. This thin layer chromatography mainly involves two different phases for their separation of different compounds. One is stationary phase, another one is mobile phase. The stationary phase should be highly strong adsorbent and the mobile phase should be a combination of different solvents. For example, butanol and acetic acid can be used in combination. The stationary phase in thin layer chromatography should be a strong adsorbent, whereas this forms a 0.25 to 0.5 mm thick of adsorbent layer like silica gel, which is used as a polar substance and also can be used as aluminum oxide, and sometimes magnesium silicate can be used as a stationary phase. This stationary phase should be adsorbed onto an inert support medium so that the complete stationary phase can be composed of. So the stationary phase plus support medium forms the complete layer of inert material for the separation of different compounds. The principle of thin layer chromatography mainly involves the partition coefficient, that is partition of solute between the mobile phase and the stationary phase, whereas the solute moves in the direction of solvent flow at the rate that is determined by the solubility of solute in the mobile phase. Whereas thus the compound with high mobility is more attracted towards the mobile phase than towards the stationary phase. In this diagram, the solvent that moves towards the compound is based on the time, so that the spot is placed over the thin layer paper and this spot will move towards the top of the paper with respect to time towards the solvent flow. So this is highly based on mobility and solubility of the compound with the mobile phase. In thin layer chromatography, mixture of sample is placed as a spot on the TLC plate. So this spot will move towards the compound with the help of capillary action. The spot contains both polar and non-polar molecule, whereas this gets adsorbed onto the silica gel, that is adsorbent in thin layer chromatography, contains a silanol group of OH bonds. So that this forms hydrogen bond with the polar molecule and the OH groups of the silica gel. As the solvent rises due to the capillary action, the mixture gets separated, whereas the polar compound gets retained due to the hydrogen bond between the OH group of silanol molecules in stationary phase, and non-polar molecules moves towards the mobile phase and gets separated. In this thin layer and paper chromatography, after the mixture gets separated, this has to be analyzed with following ways, whereas the spots in the paper and thin layer chromatography can be detected in 4 different ways. One is by their natural color, or by their fluorescence, or by their chemical reactions. Whereas the paper chromatography, the chemical bonds that is formed between the solutes and the solvents can be adsorbed onto the stationary phase, which can be viewed through various reagents. For example, amino acids can be viewed with the help of ninhydrin reagent, or it can be detected by their radioactivity. The paper or plate remaining after the experiment is shown as a chromatogram. In this chromatogram, the different colors represents the different compounds that get separated based on their polarity with respect to time. After this, the expression of spots can be done with the help of RF values. The spots are usually identified by comparing the known standard values of RF values of different compounds, whereas this RF value is the ratio of distance travelled by the solute to the distance travelled by the solvent. Under similar conditions, a compound should always travel with the same speed, whereas its identity can be found by comparing the distance that is travelled towards the solvent. Whereas the RF value of a particular compound can be calculated with the distance travelled by the compound divided by the distance travelled by the solvent. In this diagram, X represents the distance travelled by the solvent, whereas the Y represents the distance travelled by the compound. For determining a compound, if the RF value is closer to 0, the solute that has highly affinity towards the stationary phase and retains there. Whereas if the RF value is closer to 1, this says that the solute has high affinity towards the mobile phase and it will travel towards the mobile phase. Whereas the final chromatogram can be compared with the chromatogram of known mixtures to find out the sample compound based on the RF values. There are certain factors that affects the nature of chromatography. So here are some of the factors that affects the separation other than the chemical nature of substance. Whereas first one is temperature. In this, if temperature is highly soluble towards the compounds, this should be fixed with a fixed temperature for optimum results. Second one is composition of solvents. Since most of the compounds that get solubilized to one of the solvent, it should be highly based on different combination of different solvents should be chosen correctly. And then any ionized impurities that is found on the supporting medium will get bind to the most compounds, that is oppositely charged ions present on the compound. Therefore, this reduces the mobility of different solvents and retained over the stationary phase. Here we have compared the TLC and paper chromatography. In this, TLC have wide choice between the different using compounds for adsorbents in stationary phase, whereas in paper chromatography only cellulose can be used as stationary phase. In TLC, it has better resolution and also gives quantification. Whereas in paper chromatography, this shows low resolution and allow for quantification. In TLC, we have compact zonal spread, whereas in paper chromatography, we have extended zonal spread. Here, we have some advantages of thin layer chromatography and paper chromatography. Some of them are, it has greater resolving power because there is less diffusion of spots. And also it has greater speed of separation, whereas this also have wide range of materials used as a sorbent. Here we have given the applications of TLC and paper chromatography. First one is purity of any sample. The sample purity can be determined by comparing the known with the standard compound, so that the impurity can be detected easily and also extra spots can also be detected easily. Next one is, one of the most important application of TLC separation is based on the multi-component separation in pharmaceutical formulations. And third one is, it is highly used in food and cosmetic industries. The TLC highly used for separation and identification of colors, sweetening agents, various preservatives and also various cosmetic products. Let us come to the end of this session. Hope you have all understood about the principle and working mechanism of thin layer chromatography and paper chromatography. In forthcoming lecture series, we can see in detail about the principle and working mechanism of HPLC, that is high performance liquid chromatography. Thank you.